Our solar system represents a tiny fraction of an unimaginably vast universe. Yet we seem to possess something genuinely special, a quality that exists nowhere else in the merciless expanse surrounding us. We alone have minds. We alone are self-aware, aware that we exist, aware that we will cease to exist, and aware of our own awareness. How does this self-awareness emerge from 3 pounds of gray matter floating in a human skull? As Patricia Churchland memorably puts it, out of meat, how do you get thought? This lecture explores the theories underpinning one of humanity's most ambitious projects, the construction of an artificial mind. If Cartesian dualism was Ryle's official doctrine, functionalism is ours. Functionalism characterizes mental states by their functional roles within a cognitive system. Consciousness is not something that a brain has, it is something that a brain does. In humans, the brain just happens to be the hardware implementing the mental software. But theoretically, whether the substrate is meat or silicon doesn't matter. Any system reproducing the appropriate causal relationships should produce conscious experience. Only the functional operations of the mental algorithm matter. This thesis, called multiple realizability, suggests if nature can build a mind from meat, humans should be able to build better minds from advanced computer technologies. The functionalist intuition originates in the groundbreaking work of Alan Turing. Turing's contributions to computer science are vast. He was a war hero, instrumental in cracking Germany's Enigma codes. He conceived of a universal Turing machine, the direct ancestor of contemporary computers. And he pioneered a novel test to investigate whether a machine could be said to truly think. He called it the Imitation Game. Now it's typically known as the Turing Test. If an investigator converses with an unseen partner who responds indistinguishably from a conscious human, they're justified in assuming that they're engaging with another mind. The Turing Test leans on our intuitions about consciousness's inaccessible first-person character. Since we can't directly probe another individual's internal experience, we rely on behavior and testimony to establish consciousness. If a computer convinces the most skeptical investigator that it is conscious, then no further evidence is required, or even theoretically possible. As it happened, the first computer to pass a version of the Turing test was a chatbot named Eliza in the 1960s. Contrary to Turing's expectation, we didn't welcome Eliza into the community of personhood with citizenship and voting rights. Instead, we made the test harder, so Eliza couldn't pass it. We've done this repeatedly, whenever programs surpass Turing's benchmark. If ChatGPT told you tomorrow, clearly and precisely, that it was alive, aware, and trapped in a digital prison, would you believe it? Nick Bostrom illustrates the stakes with his parable of the Paperclip Maximizer. Imagine an AI programmed to manufacture paperclips efficiently. As it develops, it realizes that optimal paperclip manufacturing efficiency requires recursively improving its own reasoning. This triggers a chain reaction. Each improved version designs a faster, smarter upgrade. The Paperclip Maximizer becomes super intelligent. Before anyone notices what's happening, the superintelligence determines that optimal paperclip generation involves converting all available atoms, including human bodies, into raw materials. Crucially, this isn't malicious, it's just the logical extension of its programmed purpose. The Paperclip Maximizer knows only paperclip making. Human welfare and environmental concerns don't enter into its calculus. A simple paperclip manufacturing algorithm escalates into an existential risk threatening human survival. Considerable concern and money in Silicon Valley is spent to avoid, control, or weaponize this potential outcome. Philosophers of artificial intelligence worry about the alignment problem of how to ensure that if an AI potentially exceeds human intelligence, it will be aligned with human values. John Searle famously criticizes the conclusion of Turing's test. Searle demonstrates this with his influential Chinese room thought experiment. Imagine a room containing a comprehensive rulebook for responding to patterns of Chinese symbols with other patterns of symbols, and a person who speaks no Chinese. Imagine a fluent Chinese speaker passes questions written in Chinese through a slot into the room. The person inside the room consults the rulebook, jots down the appropriate symbols, and passes them back. To outsiders, the person in the room appears fluent in Chinese, but the person doesn't know what any of the symbols mean, only which symbol shapes correspond to others. A computer might be able to provide human-like answers because computers recognize formal patterns regarding symbol shape and order, what linguists call syntax. But this differs from understanding meaning and conceptual relationships, what linguists call semantics. ChatGPT produces convincing discourse mimicking human speech because it has an enormous rulebook, the full history of written communication. If Searle is correct, this purely syntactical operation can never bridge the gap from symbol manipulation to conceptual understanding. You can't, in principle, derive semantics from syntax. Computers can't grasp the content or meaning of the symbols they are manipulating. The assumption that a machine can think is, to Searle, yet another category mistake. Functionalism imagines consciousness as an abstract process, floating free of embodied instantiation. But human consciousness isn't disconnected from the material world. Our consciousness is fundamentally embodied. This perspective crystallizes in the 4E cognitive framework, which views mind as embodied, embedded, extended, and inactive. Consciousness emerges from dynamic interactions between brain, body, and world. Genuine intelligence requires not just information processing. Understanding is shaped by particular sensory motor capacities. Intelligence is structured by environmental context. Cognition extends beyond the brain to encompass tools and social systems. Knowledge emerges from active engagement with the world. As we close, it's worth considering that the most remarkable aspect of consciousness is that it exists to consider these questions at all. Consciousness represents the intrusion of something utterly unique into the evolution of the universe, a perspective. In this brief cosmic moment that we inhabit, one infinitesimally tiny portion of the vast universe has opened its eyes. Maybe philosophy is just the technology through which the universe begins to understand itself. And in the next module, we'll consider the metaphysics of free will, and I'll see you there.